In sections 3.3 and 3.4, we are going to be looking at how to factor polynomials of degree higher than 2, which means not, the quadratics, which means third power, fourth power, and then finding the zeros once we get those. So you're going to be finding the zeros like we did in section 3.2 from factored form. But we got to figure out, okay, how do we get from expanded or standard form to factored form? So how do we factor polynomials with a higher degree than 2? Well, it's kind of similar to factoring quadratics. If you look at these factors and this expanded polynomial, what you'll notice is, well, you may notice, probably not, if you take -2 times -3 times 4, you get 24. So it still works the same way, that we have to be able to get our numbers have to be factors of the constant term. The difference is when you're dealing with two choices with quadratics, well, your field is narrowed down greatly. When you have polynomials of a degree 3 or higher, there could be lots of choices that could work to give me this value. So we can't do trial and error, or we'd be here possibly for a long time, okay? So we're going to use something called synthetic division. Synthetic division is a way that we can divide and see if factors are divisors of a polynomial. And the good thing about synthetic division is we use only numbers. If we have a divisor in the form x minus c, kind of like x minus 2, we use the opposite sign. So in other words, if my factor is x minus 2, my divisor would be positive 2, and vice versa. So let's look at how it works. So I have my divisor or my test factor, and doing synthetic division, I'm going to use the 4. Now, you've got your divisor. What goes up here are your coefficients and your constant with the signs. So I've got a 6, I've got a -26, and I've got a positive 12. And then what I generally do is I create like a little grid. So the process is we bring down the first number, just drop it into the quotient row, because this is the quotient row. And then the process is to multiply and put that value up into the next box. So 4 times 6 is 24. Now, since the 26 is negative and the 24 is positive, I combine my like terms, and I get -26 and 24 is -2. I repeat the process. I take 4 times -2 to get -8. 12 minus 8 is 4. So I'm finished because I've reached the end of my numbers. So this 4 is what we call our remainder. My quotient is 6x minus 2. So how do I get the quotient? Well, we can work backwards. If this is our remainder, this is the number without an x or the constant term. This is my coefficient times my x, and I keep working backwards. The other way to look at it is, since we started with 6x squared, our quotient is going to start 1 power smaller. Okay? So let's look at another example. So I want to divide 2x cubed plus 7x squared plus 5 by x plus 3 using synthetic division. So again, we use -3 as our divisor, and our coefficients are 2, 7, 0, and 5. Now, we use the 0 since we do not have an x term. I have an x cubed and x squared, but no x. So I have to account for it. So again, I use my opposite sign. I throw in my 2, my 7, my 0, and my 5. And then I can create my little grid of boxes, bring down the first number. Okay, so there's nothing down here. I just went over the edge a little bit. So -3 times 2 is -6. 7 minus 6 is 1. -3 times 1 is -3. I've got -3 and 0, so it's just -3. -3 times -3 is 9. 9 plus 5 is 14. So my remainder is 14. My quotient is 2x squared plus 1x minus 3. And again, how did I get that? We started with a cube. Our quotient is 1 power less, so that's 2x squared plus x minus 3. Or we work back from our remainder. Constant term, coefficient of x squared. So we're going to use synthetic division to show that x plus 3 is a factor of this polynomial. Now, to be a factor, you must have 0 remainder, just like numbers. You know, 2 and 3 are factors of 6. 4 is not a factor of 6. 2 and 3 are factors of 6 because if I take 6 divided by 2, I get 3 with no remainder. If I take 6 divided by 4, I have a remainder of 2. Okay, so we have to get 0 as a remainder. So if I want to show that x plus 3 is a factor, my divisor is -3. I fill in my coefficients, and we notice we have a 5th power, 4th power, 3rd, 2nd, 1, and constant. So there will be no zeros here. Just watch your signs. Again, as I said, or as I say in class often, many of our mistakes are attributed to sign mistakes. So I complete this process. -3 times 2 is -6. -6 plus 5 is -1. -3 times -1 is +3. 3 minus 2 is 1. The only reason I'm subtracting is because this is positive, this is negative. -3 times 1 again is -3. Combine my like terms. 2 minus 3 is -1. -3 times -1 is +3. 3 minus 2 is 1. Last one, I multiply. I get a remainder of 0. So that's how I know that x plus 3 is a factor, okay, of this big polynomial. My remainder is 0. Now, there are other ways to determine remainders. It's called the remainder theorem. I could certainly, and I will talk about this more, but I don't want to address it too much today, but you could certainly put -3 into this equation for all my x's and see if I still get 0 as an answer, okay? But we'll talk about that later. I prefer just to go ahead and do this because if I'm going to factor things, I need to do synthetic division to get my quotient anyway, all right? But at any point, that's how you do synthetic division. That's how you determine if something is a factor. and then we could continue to factor these things completely, which is what we're going to do next. So we're going to use this process to help us factor polynomials of degrees higher than 2. All right, so let's look at that very first one that we were looking at earlier. I had it in expanded form and factored form. So for this polynomial here, 2, 3, and 4 are all factors of 24. So basically every rational zero is going to be a factor of the form P over Q, where P is a factor of the constant term, Q is a factor of the leading coefficient. In this case, it's 1. So we only need to look at the constant term here. And we also must consider positive and negative factors of both terms. So if we were to factor this from the start, we would look at positive and negative factors of 24. There's a lot of them, okay? So we would look at positive negative 1, positive negative 2, 3, 4, 6, 8, 12, and 24, okay? So let's look at listing potential zeros. We're not going to factor, we're not going to try anything, just listing what are possible zeros. So if I was going to attempt to factor this, my leading coefficient is 1. I only need to consider factors of 2. So my potential zeros are positive minus 1, positive minus 2. So that's just how we do plus negative 1 plus negative 2. So if we were doing synthetic division, we would try 1, see if we get a remainder of 0. If we don't, negative 1, get a remainder of 0, so on and so forth. So here's one where it's a little different, okay, because I have a leading coefficient of something other than 1 and a constant term of 4. So we have to set it up like this. My potential zeros are factors of 4 paired, not reduced, but paired with factors of 2. So this is going to be plus minus 1, plus minus 2, plus and minus 4, paired with factors of 2. Let me see, I keep getting this flashes of light, really annoying me. Probably annoying you too. All right, so what I do with this next is I pair numerator with each denominator. So 1 over 1 is 1. 2 over 1 is 2. 4 over 1 is 4. So really it is factors of 4. Now I got to pair each numerator with the other denominator. So plus minus 1 over 2, my glare is just terrible, is plus minus 1/2. 2 over 2 is 1. I already have that. I don't need to worry about it. 4 over 2 is 2. So here are my potential zeros. Okie dokie. So let's find all zeros. Okay, let's find all zeros. All right, so what we're doing again is we're solving. Okay, we're solving x cubed plus 3x squared minus 4 is 0. Okay, so my potential zeros are factors of 4. I'm not worried about negative 4. It's just factors of 4. And so that is positive negative 1, positive negative 2, positive negative 4. So what I'm going to do is I'm going to start, and I get organized. I'm going to try 1 as a divisor, negative 1, and go on till I get a 0. If I get a 0 at 1, then I'll show you how to proceed. Okay, so I will try 1. So I set up my synthetic division. Keep in mind, we do have a missing x term. So I've got to account for that with a 0 here. Bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. 0 plus 4 is 4. Do it again, and then I get a remainder of 0. Okay? So, 1 is a 0. X minus 1 is a factor. My quotient is x squared plus 4x plus 4. So what we've done is we've taken this equation right here, and we have factored x minus 1 and taken that times x squared plus 4x plus 4. Now I can go back and factor this as I've always done. I mean, you can keep doing synthetic division, but there's no need. And this is x plus 2, sorry, I skipped a step here, times x plus 2. Factors of 4 that add up to be 4. And then what we kind of do is, since we multiply it by itself, we square it, okay? So I get x minus 1 times x plus 2 squared equals 0. So therefore, my zeros are 1, negative 2. So just like any factors work, if I multiply all this together, I get what I started with. Okay. So let's look at another one. We've got, again, we want to find zeros for 2x cubed plus 11x squared minus 7x minus 6. So my potential or possible zeros, we have to do our pairing here. So plus minus 1, 2, 3, and 6 over plus minus 1 plus minus 2. So my potential zeros, 1 over 1 is 1. So we're going to get all the numerator straight off the bat, because 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, 6 over 1 is 6. Then I look at 1 over 2. So that's plus minus a half. 2 over 2, well, I've got that at 1. 3 over 2 is 3 halves. 6 over 2 is 3. I already have that. So these are my potential zeros. So again, I'm going to try right with 1. I go right in order. So I'm going to try 1. So 1, and I've got my coefficients, 2, 11, negative 7, negative 6. Create my boxes. Bring down the 2. 1 times 13. 13 minus 7 is 6. I go through all that process. I'm skipping a little quickly just because I don't want y'all on here too long. 1 times 2 is 2. 2 and 11 is 13. 1 times 13 is 13. Subtract 13 minus 7, so on and so forth. So again, so 1 is a 0. X minus 1 is a factor. And 2x squared plus 13x plus 6 is the quotient. So what I've done is I've taken 2x cubed plus 11x squared minus 7x minus 6 equals 0. And we factored it into 2x squared plus 13x plus 6. So I can factor this. Now I know, sometimes this is not our favorite type of factoring. Okay, so however you do it, AC method, whatever. 2 times 6 is 12. 1 times 1 is 1. 12 and 1 is 13. Okay, so these are my factors. And my zeros, a little bit tougher here. So, what we have is x minus 1 is 0. 2x plus 1 is 0. And x plus 6 is 0. So x is 1. X is negative 1/2. And x is negative 6. So those are my zeros. Okay, so I'm going to stop there. I will try to remember to do the last example in class, and we'll do more of these in class as well, just to get some more practice. All right, so that's it. We'll see you next time.